All right, class. Today we're talking about the dot product between two vectors. All right. The dot product involves the dot and involves the product between two vectors. So we want to remember now is what are some of the things that you can do with vectors that we've talked about so far? If you have vector A and you have vector B, what are some things that you can do with those vectors? You can add them. You can subtract them. Okay? Can you? Oh, really? Have we talked about multiplying vectors? We have not. What happens? What do you get when you add or when you subtract a vector? What is the answer type?
Like what form is it in?
It is not a number. Like if I've got vector A and I've got vector B and I add them together, the same color. And this thing is A plus B. What is that thing? It is, we could call it C, but what type of a thing is C? Another vector. The answer type is a vector. And if you remember, the way that you can do that is you take AX plus BX, and then you have AY plus BY. That's what the answer is. So what does it mean to multiply vectors? Is it AY times BY, or AX times BX, and AY times BY? No. I mean, you could do that, but it's really not very useful. I mean, there's a lot of different things you can do, but they're not very useful. What mathematicians have found out, however, that if you multiply them and do some other stuff in a certain way, then you get an answer, which is actually very helpful. Okay, so this obviously was helpful because it told us what, if this was a force and this was a force, then this is the resultant force. It would be as, the object would move as if you just had one force in this direction with this magnitude. Or if you traveled this way and then you traveled this way, then it would be as if you had started here and traveled just along this entire path. You'd end up at the same place. So with multiplication, this is how they write it. They say vector A dot vector B. So they actually make a dot right there. That's why it's called the dot product. Okay? You remember way back in like junior high when you had the dot, or maybe even elementary school, if you were multiplying two things, sometimes you could put the dot right there. So this is what it is. The answer for dot product is a number. More specifically, it's a scalar. And this is what that number is. It's AX times BX plus AY times BY. So for example, if vector A was 7, 10, and vector B was 2, 4, then A dot B is defined as 7 times 2 plus 10 times 4, so 14 plus 40, 54. All right? Now you might be saying, okay, A dot B, 54, big deal. What does that tell us? Well, it doesn't tell you anything directly, okay? But it can be used, so that right there, to tell the angle between the vectors. So a 7, 10 vector would look like over 7 up 10, so that would be kind of like something like this. Great. And 2, 4 over 2 up 4, maybe something kind of like that. There's vector B. That's really incredibly small, but sorry. There's an angle in between those two, between A and B, theta. This 54 is going to help us figure out what that angle is between the two of them. Now, in case you're skeptical, someone might say, oh, if we need to find that angle, couldn't we just like draw them right here and figure out what B is, and figure out what that angle is by finding inverse tangent? Then can we figure out what A was by figuring out its inverse tangent, and then just do inverse tangent minus inverse tangent, you know, like do something like that? And the answer is, yeah, you could, but with dot product, we're going to be able to find a way that's way easier than doing inverse tangent, absolute value, and all that stuff like that. Dot product, here in a minute, I'll show you, we can get something really nice, okay? So here's your main formula, though, that you need to memorize, or at least have boxed somewhere for quick reference. Dot product, A dot B, is AX times BX plus AY times BY. You may wonder, why don't they just call it the product? And the answer is, because there is another thing called the cross product of vectors, which looks like this. A cross B.
Oh, wow.
Remember another symbol that you'd use for multiplying was an X?
Mm-hmm.
Yeah. So this is the dot product, and it has a certain operation for it. This is the cross product, and it has an operation for it as well. Unfortunately, well, maybe fortunately for us, for y'all, but cross product is only defined for three-dimensional vectors. Something that has an X, a Y, and a Z, okay? And that's a little bit beyond the scope of this course. But it's some pretty neat stuff, some pretty neat mathematical stuff, and if you are into computer science, two-dimensional arrays make a really great way of, an easy way of finding cross product. But we're not right now, we're in pre-cal. So anyway, let's talk about how we use this dot product. Go one big. All right, so how do you use the dot product? We'll need to draw a quick picture here. There's vector B. There's vector A. See if y'all agree with me on this one. That's also vector B. Agree?
Mm-hmm.
Same direction, same magnitude, just a different starting point. See if you agree with this. Negative vector A.
Mm-hmm.
Mia? Let's see if you agree with this. B minus A. Remember, geometrically, when you were subtracting vectors, it was just like you were adding the negative. So, vector B plus negative vector A is going to give you B minus A. So, head to tail. It's the same as we're going from here to here. Along that. Does that make sense? Some people might think A minus B, like this is A minus B. It's not. It's actually from here to here. That's B minus A. Okay. So, that being said, the reason we just do all of that is what I really want is I want a triangle. I want a triangle that looks like this. Vector B, vector A, and vector B minus A. I want to focus in on that triangle because what we're trying to find is this angle right here, the angle between those two vectors. Okay? Now we're going to go back to the well here and visit an old friend, the law of cosines.
Oh.
The law of cosines said that any side squared is equal to the sum of the squares of the other two sides minus 2 times their product and the cosine of the included angle. Remember that?
Mm-hmm.
Sure.
Of course you did. That was this side squared equals this side squared plus this side squared minus 2 times this times this times the cosine of this. We did it, and we're going to write it again here. So this side over here squared. So magnitude of b minus a squared equals magnitude of b squared plus magnitude of a squared minus 2 times the magnitude of a, magnitude of b, times the cosine of the angle in between. Oh, it's so nice, so wonderful. So remember where we're going with all this. We're trying to find out what good is that dot product. Well, we got to take a few steps to figure that out. So b minus a squared means b minus a times b minus a. Leave this alone, magnitude of b squared, magnitude of a squared, leave all this other stuff aside. 2 times magnitude of a, magnitude of b, cosine of the included angle. Alright? It's really cold when you walk in and it's really hot when you walk out. I'm not sure what's going on with all this here. Maybe it's going to be like 90 degrees out there today. It's in the bar. But it's nice. Not yet. B minus a, let's go class. That's going to be b times b, so that's going to be magnitude of b squared. Then b times a, so minus a times b. And then another minus a times b, so minus a times b. And then negative a times the negative a is a positive a squared. I'll just write it like that, positive a squared. Equals everything on the left here side. Stays the same. Magnitude of b squared, magnitude of a squared, minus 2 magnitude of a, magnitude of b, cosine of the angle in between them. Now we're rolling. Look at this. Look what I've got on the left-hand side and the right-hand side. What do y'all see that's the same? I see a b squared. So if I subtract a b squared from this side, I subtract a b squared from that side.
And then the negative 2a, no, yes.
I do have a negative, you see, I do the same thing with the a squareds, right?
No, the negative 2 and then the magnitude of a and b.
Okay, yep. So this is negative 2 a dot b, right? So that's a dot b. Now over here we have negative 2 magnitude of a, magnitude of b, cosine theta. Those are not the same thing. A dot b is ax times bx plus ay times by. Over here this is find the magnitude, so Pythagorean theorem, multiply. So those aren't the same thing. But the negative 2 is, so we can divide both sides by negative 2, and we get that the dot product is equal to magnitude, cosine angle. That's actually pretty helpful right there. And that in itself is an awesome formula, because we know that this is just, it helps us out in physics a lot. I'll just tell you that. If you end up taking calculus-based physics, this is one of the things they kind of expect you to know, and that is the dot product is equal to the magnitude, cosine theta. It also equals the x's times the y's, and then you add those together. But what we are interested in is that angle right there. So I'm going to say cosine theta equals, I'm going to imagine this is, leave this all by itself, divide both sides by magnitude a, magnitude b. So a dot b divided by magnitude a, magnitude b. Here we are, final answer. Nice formula. Theta is equal to inverse cosine of the dot product divided by the magnitude, the product of the magnitudes. So simple, right? I mean, isn't that? I told you it was going to be easy. This theta is equal to the inverse cosine of the dot product divided by the product of the magnitudes. Okay, and maybe it's not that simple. Let's go ahead and do a quick example here. So let's say that vector A is 2, 3. So 1, 2, 1, 2, 3. And vector B is, we'll say, -1, 6. Something kind of like that. Here's vector A, here's vector B. And we are prompted, find theta. Find the angle between them. Now, like I said, one way you could do is you could do inverse tangent, and subtract those, but we're going to try using our new formula here. Okay, so according to our formula, theta is equal to inverse cosine of the dot product. Dot product we saw a few minutes ago is multiply the x's, multiply the y's, and add those answers together. So 2 times the -1 plus 3 times the 6. All divided by magnitude of vector A. So how do we find the magnitude of an angle? Mason, how do we find the magnitude of a vector? I mean, how do we find the magnitude of a vector? Pythagorean theorem. Yeah, that's you.
Whoa, yeah.
You should have jumped in and interrupted him. All right? Pythagorean theorem. So that's going to be the square root of 2 squared plus 3 squared to find the magnitude over here. So that's square root of 4 plus 9, so square root of 13. Class, how are we going to find the magnitude of vector B? Pythagorean theorem. So that's going to be square root of 1 squared, which is 1, plus 6 squared, so 36, so square root of 37. So we have inverse cosine of, let's see, -2 plus 18, so 16 over square root, somebody multiply real quick for me, 13 times 37. Where are you on? Sure. Let's just go ahead and do that in our calculator, see if we get a realistic answer. Inverse cosine of 16 over root 481.
$43.2.
43.2 degrees. Are you in degree mode?
Yeah.
Does that seem like a reasonable answer based on my very quick sketch?
Yes.
43 degrees? Yeah, I mean, it's not, I mean,
Close to 45.
yeah, it is actually. It's an acute angle, and we've got an acute angle right there. So, yeah, I think that's pretty good. Let's see. There is some interesting things that happen with the dot product when our angles are perpendicular to each other. And we will discover that tomorrow. Okay? So today we talked about what the dot product is. Answer, it's a number. And a little bit about how it's useful. The answer is, it tells us very quickly how to find the angle between two vectors.